Hi everyone, can you hear me okay in the back? Thanks. My name is Frank Fan. I really appreciate the opportunity to have me here. I recently joined the Pernix as an APAC system engineer. Prior to that, I was working for Datacenter as a consulting manager, and also IBM as a virtualization specialist a while ago. I recently just attended VMworld. I came back this week. And during the session, lots of people visited Pernix booth. The one guy came to me and he told me, after I listened to your presentation and also the demo, I finally found the best solution for our environment to address our performance needs in the most cost-effective way. So I was not surprised because that's exactly how I felt when I first time looked at Pernix data, and also it's an eye-opening opportunity for me to look into the product and also join the company a few months ago. Just want to have a quick question. How many people here have heard of Pernix data? Ah, awesome. Our marketing works. So the company founded 2012 by Pujin and Satyam. Satyam was one of the first VMware engineer joined 10 years ago. And he was the head of the VMware storage team. He came up with the idea to use software and leverage server-side flash to address those storage needs. And we have people from NetApp, VMware, they all have very deep insight about how virtualization, how storage works. Since we released the first product last year, we have around 200 customers globally, and it's still growing very rapidly. We are expanding offices in various regions, including ANZ. In ANZ, we have Simon Williams, who's sales, and I'm a system engineer. We have partners, about 10 to 15 partners, including Fujitsu. We have customers in as Blue Energy, and also we have customers in Sydney, Brisbane. Fujitsu, as one of our main partners, is going to consider our solution not only to address their own performance needs, but also to use that for their customer as well. So today, I'd like to share my journey when I consider storage design. In my past role, I had the opportunity to get involved also storage design and virtualization design. Can I ask a question? How many of you have done storage design? Do you think it's a very easy exercise? Is it just like walking in a park? People nodding head. It's not easy at all. Like today, you have this big box and have play many roles, not only capacity, but most importantly, performance. According to VMware, probably over 70% of the call related to storage bottleneck problems, and most common mistakes related to storage. Because it's not easy. When you first challenge, do you size for peak or size for average? If you size for peak, you spend lots of money up front, and before you have workload loading up, it's sitting there idle. It's not best use of investment. If you size for average, potentially you are at risk. You can't accommodate that peak requirement. It's a hard question, right? Secondly, is it easy to accommodate the future need? Is that easy to design a future-proof solutions? Because it's very difficult to assign activities with assumptions. It's very hard to predict the future workload because it changes all the time. The decision you make today may or may be suitable for the future needs. Pernix data offers the market the solution to address these challenges. Instead of having the big box to do everything, this is what we suggested. We decouple performance design from your capacity design. We don't touch your backend storage. We still let the backend storage continue doing whatever it's good at. Right? It's designed in that way. It's persistent tier, it's reliable. You continue to do your backup replication as a data service, you continue to serve the customer to meet their capacity needs. However, for performance, we introduce intelligence in the software layer. We have model running at kernel level and aggregate all the resources as your flash to serve your performance needs. So this is a shift of the mindset. To me, it's massive impact. It's not about just acceleration itself, and also about the vision of the company really inspired me about the intelligence here. The benefit is very obvious. Because you decouple this design, performance design from capacity, you can best meet your performance needs by leveraging flash memory. And you can definitely reduce your latency, provide massive IOPS and throughput. And in parallel, and make your storage design a lot simpler. You just use this box to cater for your capacity needs. And it reduces the cost per gigabyte per storage. You don't have to go with very fast hard disks. You don't have to go with very expensive RAID level. You don't have to purchase way expensive features at the back end. So that's our vision. When we talk about latency, this where you put your flash is very important. This is a very simple diagram to show how your I/O go over your network and hit your backend storage. Actually, 6 steps here. Now you can see if you have a storage performance issue, what are you going to do? Probably you need to look at here first. Do I need to have a better RAID level? Do I need to consider the throughput of my storage controller? Do I need to consider upgrading my storage fabric? And lots of vendors realized with the price of flash dropping down, lots of solutions is here to have flash in here. It's good you have a faster box. But from Pernix data perspective, you still don't change that storage architecture, which you still have that box, which is shared by all the virtual machines and hosts. Sooner or later, you need to consider upgrade. You need to address your potential performance bottleneck here. Do you think having flash here is the best solution? The answer from Pernix data is like this. Pernix data believes the best way to have flash here. It's very obvious reasons. If you have flash here, you have shortest paths to your virtual machine. When VM issues I/O, it gets served by the flash straight away. It doesn't have to go over all your storage fabric, so many steps to hit your backend storage. And you don't need to worry about potential queuing or bottleneck, all the layers here. That's very simple and very, you can, and another thing is you have flash here, which provides that exclusive need for your performance. We don't use that for capacity. Another thing probably really inspired me, not only about acceleration, it's about intelligence. What does it mean? What intelligence mean here? If you talk about virtual machine issues I/O, when I/O sent from issue initiated by the virtual machine go to your VM kernel and then go out your hypervisor, it loses your identity. Maybe it's really intensive, write intensive, sequential, or random, doesn't matter. It's going to be random I/O when you go out to hypervisor. Backend storage, cool, it's fast, but it doesn't have that knowledge about which I/O belongs to which VM. And it's not going to provide that storage policy, which is customized for the virtual machine. So if you go back this solution, because Pernix.FAP is running at hypervisor. It knows exactly which I/O belongs to which virtual machine, and knows I/O profile, and also can definitely cater, define a customized solution to meet their needs. This is something we always looking forward beyond the acceleration. We can do a VM-centric policy. It's not only about acceleration. This is industry trend. You can see everything people talk about software-defined. You can look at NSX or vSAN. They are going to move up that intelligence from your hardware layer to software layer. That really aligns with Pernix cloud's vision. So the solution is very simple. Pernix cloud has three components. The first one is about that extension. So we have that module installed on each ESXi host. It can be installed by WAN or by the command line. This is purely running at the kernel level. And you don't have to install any virtual appliance. You don't need to change anything. The second component is about the management server can be run on any Windows 2008 or 2012 machine. This machine here, management server is only used to manage these kernel modules, configure policy, and also read information from the kernel. A third component is the plugin. We integrate with web client and with C# client. So you don't need to learn anything new. As a system learning, you can use a vSAN to manage everything. Another thing I really like to highlight is about this solution is vendor agnostic. We don't install anything on the virtual machine. We don't install any driver there. And we don't install anything as backend storage. You continue using your existing systems. In terms of SSD devices, we support any devices on VMware HCL, and regardless SSD, PCIe. And new version, we're going to support memory. This is a really exciting feature because it's the first time in the market you use that volatile media as a storage acceleration media. So, and also you have truly clustered solution. You can have different type of devices on the host. You can mix different type of media if you like. When I say FAP provide a truly clustered solution, it means we support all the built-in features of the vSphere. Most of the situation people concerned, what if you have VM moved from one host to another? Are you going to lose your page? No. FAP is smart enough to understand if I/O issues here, there's no local flash available because the VM just recently moved from one to another. It will go across the network to retrieve data. And then we'll get back to the virtual machine. So the beauty for this is we don't just blindly mirror data all the time. We only go over network to retrieve data if needed. Next time, if we think, okay, this data will be accessed again and again, we'll gradually build the local footprint here. So the subsequent read will be served by a local flash. It will be a lot quicker. Regardless, our BRS Vmotion will also support that. Now I'd like to introduce some terms here. We use these terms all the time, write back and write through in the industry. Write through means when the VM initially write, it will leave a copy in your local flash. In parallel, the I/O will be sent through the network and reach your storage array. Once the VM receives acknowledgement from both the flash and a backend array, the I/O completes. Which means by doing this, it doesn't accelerate your write because your effective write latency still aligns with your latency of your backend storage. However, the subsequent read will be getting a lot quicker because we have hot data here. The read will be immediately served next time. That's write through. Write back when the VM initiates the write, and it leave a copy here and acknowledge back to the VM straight away. It's a lot quicker because it's shortest path. The VM doesn't have to understand what's happening in the background. VM continue doing whatever it wants to do. In the background, FVP will assess the capability of the storage. If the storage is capable to deal with the I/O, straight away the I/O will be displaced from here to a backend storage. If at that time the storage, backend storage, have some issue, have potential bottleneck, FVP is going to even out I/O over time and send the I/O to the backend storage without overwhelming the storage. So by doing this, it's not only accelerate read, but also write as well. Because you can see here it's responding very quick. So this is, people probably have questions. Now you have data sitting here, right? Hot data here. And you have backend storage. We don't use cache as a persistent tier. That means eventually the data will be destaged to your backend storage as soon as possible. However, you still have that very short time period. You have data here, which not here, right? What if you lose the component? What if you lose the host? Potentially you have data loss, right? We understand that's a risk, so that's the reason Pernix data introduced a replica. We call it a write fault tolerance to protect that issue. Every time when the write initiated by the VM, it's not only written to your local flash, but also written to your network peers. You can set up to 2 network peers. So if you have any disaster of the component, have disaster of your host, the first thing FVP will detect the error. Understand, now we don't have that redundancy. We lose one host. And then dissage that data from network peers straight away, so you have data safe at your backend storage. And then if it's a HA scenario, HA will kick in before the data has been dissaged to a backend storage. By doing this, you wouldn't have any data loss or data corruption issues. Here, lots of questions I have been asked is about, now you have introducing a moving part. You have a network latency here, right? What if the network latency is high? Of course, it's not as quick as your local flash. But if you look at metrics here, compared with your latency from VM to your backend storage, the network latency is still a lot better. This is our investigation shows it's about 300 microseconds compared with the big number here. You still got quick responding. Another thing I'd like to say about this architectural change. It's not only giving you acceleration solution, but also it's a platform for you to consider. Go back to our scenario in the up front. It's not very easy for people to predict the future needs when you design solution. A while ago, I was involved in a workshop with a big customer and also the storage vendor. At that time, people put a finger in the air. How many IOPS do we need? Okay, 50 per server. And then they came up with a massive number of IOPS need to be supported, which means you need to purchase a very high-end backend storage. Massive I/O can be served, which is cool. But now they realize, okay, I have this very high-end backend storage sitting there. Majority of the time is idle because they haven't got much workload loading on that. Every time when the customer loads it on board the platform, it's difficult for them to convince the cost because you purchase lots of the high-end storage up front, and now you need to charge back to the customer. Another thing is, when you reach a point, you need to do something with backend storage. It's not a trivial work. You normally need to organize the change, and also you need to make sure the new solution is compatible with your decision made in the past. The thing I really like about this architecture is it gives you flexibility. The flexibility is not only about you can have the flexibility to choose your device. Today you have 50K SSD. Sorry, I got no. 50K IOPS per SSD device. And recently in the VM world, Intel released the new generation of their SSD drives for 250K. What are you going to do? Of course, we want to pick up the greatest product with the most cost-effective product to meet your needs. This gives you flexibility to do that. You don't have to log in with any SSD vendor, and also you have flexibility to use any size if you require. Another thing is we don't do anything with backend storage, so your storage continue playing its role. You at a time when you evaluate your compute tier, probably it's a good time for you to evaluate your storage performance. You just simply add flash devices along with your compute resources. Now it's done. And you have opportunity to address your performance need in a very easy way. So this is something I'd like to show you. This is a real-life scenario from a client. And before they put the FAP solution in, this is the situation they have. They have very bad responding time from the backend storage. And as a result, from VM perspective, the responding time is not good. People complain. At this point in time, we enabled FAP solution to put the flash devices in. And this is the change have been made. The VM observed latency have been dropped from here significantly to here. Why? Because majority IOs actually are served by the flash. The VM latency aligns with your latency of your flash devices. An interesting thing is people sometimes overlook about the impact to your backend storage. It used to be here. Now the backend storage still not ideal, but a lot better than before. So, which means when you put the flash and also FAP software in, it not only accelerates the VMs already in that flash cluster, but also provide a benefit for your whole environment. So one day, the system admin put in the FAP in their cluster, and they got a call from storage team and said, "What have you done? I don't see much traffic from the backend storage." So that's the thing we have done is because lots of IOs actually never hit the backend storage. Like this, even eventually when we destate an IO to the backend storage, we destate that in a uniform way. The IO profile of the virtual machine is like this, up and down. But FAP will destate them in a uniform way and evenly. Go back to our scenario in the past. Do you size the environment for a peak like this? Or do you size the environment like this? It'll make a big difference. So now your worst case scenario is you still have probably your backend storage still need to handle this load, but it's not like that. You can purchase probably less expensive disk with less expensive rate. And when you put the FAP enable that solution, the backend storage is much happier. And just like you provide this benefit for your whole platform. So before I move on to looking at time, how much time we are looking at? Only 15 minutes. So do we have any questions at this stage? All right.
The IOPS overhead that you're showing, does that include deduplication?
Yeah, that's a good question. In terms of deduplication, I'm sure lots of vendors, they do this in the backend storage. The quick answer is no, because it is always a consideration what you can do and what you want to do. We choose not to do that in the cache level because we care about the overhead, about duplication on your computer resources. And also in terms of cache, this is a good topic about what's the usable capacity of your flash devices. Because when you say duplication, you're concerned about utilization of your flash, right? You want to minimize that footprint. I will show you in the demo straight later on. What we do is, in terms of write, in terms of when we do the duplicate, when we do the write, we do a replication from a local flash to a network flash. We only keep the data which has been destaged on your network tier. If the data has been destaged to your persistent tier, we don't care. You already have data safe, and you don't need to utilize the network peer for that additional redundancy. There's no need. So when you look at network, the utilization of the network peer is minimal because the uncommitted data is very small. Does that answer your question?
Yes.
Thank you. Do we have any other questions before I jump onto demo?
Just a quick question. Is there any workload that's more suited for this, like a VDI or SQL or?
Yeah. So we have seen lots of customers use the VDI database and also the SharePoint. Basically, it helps address the performance needs of all workload. And lots of customers have given us feedback. They have seen the tremendous improvement of their performance. But for some workloads, if they like that's the mechanism of the cache. If you have already got the data in the cache, it will respond very quickly. If you don't, you need to warm up. If you have I/O profile, will access the same data very often, you benefit most from this technology. And also, we have seen a very big improvement in the OLTP type of database transactions, reduced from hours to minutes because this data will be accessed very often. And for some workloads, like VDI, it's very classic use case because we can use that flash to address lots of boot storm, logging storm, and even address lots of static workload. VDI workload is lots of VDI workload is about write intensity because this solution definitely helps both write and read. We can see significant improvement over the VDI performance. In my past project, I did a POC, and the interesting thing is people still ask, how do you do a storage design for VDI? People mix their workload on the backend storage, used for both VDI and backend storage, because that's very common. We don't have to dedicate resource for that. But the challenge for that is you have competition with your critical workload, you have issues. I would say FAP is a good fit for that scenario because you can definitely share your workload for both server and VDI in the backend because the backend storage just address for your capacity. You have this flash here to absorb all the peak workload there. Does that answer your question? Yeah. Yeah.
How do you size?
How do you size the cache for your environment?
Yeah, thanks for that, Tim. We talk about the cache. We don't size for your total capacity. If you have 220 terabyte, this is your capacity. What we care about is the working set. That's hot data really care about. how do you determine your working set? There are many ways. One of the good sign is you look at your daily change rate of your backup, because normally that's your hot active data. It gives you a good sign. Secondly, if you know your workload very well, for example, you know your database, we can see lots of customers start with 30 gig to 40 gig per data EB server. But I'm not talking about a very high-end database, but just a general guideline as a starting point. If you talk about VDI, Windows 7, we see probably up to 100 gig per server is the most often used cache data when they boot up. There's a few things you can consider. Thirdly, we provide a UI, I will show you later, very easy to show you the utilization of your flash devices, and also the utilization of your virtual machines. If you say the utilization is quite high, probably it's time for you to consider scale up or scale out. In the later version 2.0, it's very easy to bump up the numbers if you use memory. Memory is these days you can it's not uncommon to see people have 1 terabyte memory, and you have lots of memory sitting there idle. We just simply reserve that memory for storage acceleration, and we can monitor the performance. You can easily hot add memory or shrink memory. Last but not least, what you can look at is about eviction rate. I will show you later on. Because eviction rate means how much percentage I/O are served by your flash. If your eviction rate is a bit high, that means probably sometimes you are lacking of the resources to meet that I/O. So you have to evict your I/O from the cache to your backend storage. So there are quite a few things you can consider. Overall, I would say lots of customers, I would recommend is depends on your needs, current needs, and your future needs. If you have rack server, probably the drive bay or slots is not a big issue. But if you use blades, so I normally recommend to purchase as much as possible you can afford, because you have limited slot there. So sizing is not, I don't want to overcomplicate the exercise. You have many ways to change and monitor in the future.
Another question, sorry. Can you be selective per VM, or is it for the entire host or cluster in terms of the cache?
Yeah, both. So we address all the objects from class level to host level and to VM level. Basically, you can set up policy at data store level. You can set up write through or write back. And when you change the policy at VM level, it will override the default policy.
Final question. So if you use SSDs for your flash tier, do you need to protect that in any way? Would you do RAID 1, RAID 0, JBOD?
Yeah, thanks for that. So the best practice is the question is how you're going to configure the RAID level if you use the SSD for the storage acceleration. We wouldn't recommend RAID in most situations. The reason for that is why you use RAID. Firstly, you want to have the redundancy, right? We don't care about the redundancy in the disk because I mentioned earlier, you have that write fault tolerance at your network here. We address that risk. Secondly, from performance perspective, we recommend use the JBOD, just a bunch of disks, because that's the best way to provide us throughput and better performance. And also depending on your flash, depending on disk controller, and we normally recommend we pass through. We don't use that read controller. We don't use that read functionality. Cool. Probably, Andrew, how much time we have got? Probably I jump on the
5 minutes maybe.
5 minutes already. 5 minutes left. 5 minutes left. All right. I think we'll quickly jump onto the demo. I will show you how it looks like. We connect it, and then we connect to my VPN client. For demo, given the time we have, I will just duplicate my screen. lost. I can't see here.
And Frank, would the video conference dropped out because I think you connected to the VPN.
Oh, okay. But I can't see my screen here. Laptop here. I didn't. I just changed to the duplicate. Yeah, I totally got the screen on here. If we change back.
We'll have a box going around to collect business cards. So you have the business cards ready, put them in a box, the draw for Datacenters giveaway.
Stop.
So we'll go grab the box and put the business cards ready while they're sorting this out.
And we duplicate, right?
Too technical for you, Grant.
Apparently. You said I was technical, dude. I'm an SE.
How about I just do the
Expert in PowerPoint. It's Windows 8. Alright, I'll just have to drag it over.
Alright, I'll do this.
For the sake of...
Alright, we have this session going on.
So you have to drop it off here, so you can and then share that.
Which one is one?
This
This one. I'll share that one.
Good.
Alright, so this is a demo I'm going to quickly do. How easy it is to set up the environment. Can everyone see this screen okay? I'll probably make it bigger. Alright, we have this data center. It's very simple setup. So probably I wouldn't go through how to set it up because of time constraint. It normally takes a couple minutes to set up a cluster. So I will jump onto another lab to show you some data, real life data here. This is the environment we have been running for a while. So I will show you how the cluster has been configured. If you can see this screen here, I will make it bigger. So this is to give you a dashboard about how the cluster has been configured. We have two types of flash cluster here. One is gold, one is platinum. And you have 3 hosts has been added to this cluster and have 3 resources. They are SSD drives. If you look at the bottom here, that's we call this hero number. Since we enabled this solution a while ago, you can see the 4 billion IOs have been saved off your backend storage. They never hit your backend storage. They are actually served by the flash. And they have 64 terabyte data saved from your bandwidth. All I/O requests have been doing pretty well. And if you look at the performance tier, I will show you what the benefit you get here. If you look at performance, you can see the overall performance of the whole environment from latency, IOPS, throughput perspective. If you like, you can also drill down to virtual machine level. So now we enable a solution and say what benefit we can get for the virtual machine. Now, probably I just grab a virtual machine randomly and see what happens here. And pick up this SharePoint machine and look at the latency here. It's interesting. We have see some spikes. Let me just zoom in and see what happened. At this point in time, you can see, that's interesting. You can see the data store latency is really high, it's 100 milliseconds. But it has no impact to your end user because the VM observed latency is only 1.3. Even you have the worst scenario in the backend storage, the VM is still okay because I/O actually served by the flash. The latency here align with your latency of the flash. And let's answer the question from the NID team. This is good graph you want to see. We have a hit ratio almost 100% all the time because it means 100% read actually served by the flash. If you see the eviction rate is going up, that means probably it's time for you to consider have more capacity of your flash device. If you look at the utilization here, and look at resources. This is SSD devices we put in this cluster. For the local flash, we use the 130 gig, but the network flash it only consumes 1.5 meg. It's not just simply mirror the local flash. Actually, this 1.5 is only the uncommitted data, which is the hot data, which hasn't been distilled. By doing this, it maximizes the utilization of your flash devices. And also, of course, it reduces the wear and tear of your flash devices, can expand the lifespan. We also have some advanced features. So if you want to blacklist some virtual machines, and for the network side, by default, we use the vMotion network. And also for some customers, they have 1 gig network. Perhaps they have concern about the network bandwidth. We introduced a new feature called adaptive network compression. If we detect that's 1 gig network, for any packet larger than 16K, we will do the compression before we send the packet over network. And this UI, I really love it because it's not only give you the idea about how flash has been consumed, but also give you some opportunity to see your I/O profile, and you can change here to better understand your I/O profile. You can see the read and write I/O ratio. If you understand your workload better, you definitely can apply the best policy for that workload. Yeah, that's pretty much I want to show you in terms of the performance side. When you set up the environment, it's very simple. As soon as you get your management server installed, you'll have a tab available here, Pernix Data tab. And when you set up the environment, you simply just do 3 steps here. If you click Pernix Data, we have nothing here, right? We just click the summary at cluster level. firstly, you want to create a FAP cluster. We just simply use the word APAC and click OK. So now you create a logical container. After that, you just manage with Flash cluster by doing configuration and add resources. So all the available SSD drives or memory will showing up here. I simply just pick up both of them, 200 gig SSD drive on each host, and click OK. And this pretty much, you get this 400 gig device capacity for you to use as cache. And the third step, you just add virtual machines. You can choose add data store at a virtual machine. In this case, I choose virtual machines. And you can select your policy, write back or write through. The write back, we want to protect that write fault tolerance. So you have one pin and click OK. So 5 minutes, you have your virtual machines added to this Flash cluster, and they will benefit from the acceleration. So I have been dealing with lots of customers doing installation. I believe it's a very straightforward process for them. You don't have to worry about the agent or change your backend storage. So that's what I have today. Do we have any other questions?
Actually, can people just try this in their, can people try this in their lab as well?
Yeah, absolutely. If you contact me, I have my card here. I'm more than happy to understand your environment. We can release a trial. If you want to, we release a 30 days trial. And for the partners, we release NFR licenses. I can help you to set up your proof of concept environment and walk you through how to set up. It's very straightforward.
All right. Yeah, any questions from you guys in Tassie?
Can it use RDMA, or is that on the roadmap going forward for the inter-host communications with cache?
You're talking about RDM, right?
RDMA, yeah.
Yeah, unfortunately, at this stage, the product doesn't support RDM because we always see the usage of RTM has been keeping dropping. And yeah, the quick answer is no.
No, sorry, we went RDMA, remote device memory access.
Sorry, say that device memory.
RDMA, remote device memory access, I think it's called.
Okay, so I don't think I get your question. So device memory.
That's okay, Frank.
Yeah, probably you call me afterwards. We can discuss that.
No worries.
There's a new product out from Diablo Technologies, the Ultra DIM. So it's an SSD that actually fits into the DIM slot of a server. Is there support for that?
For that architecture, I understand there are lots of new things coming out. Use a DIM or use a massive bandwidth. As long as that resource is accepted by VMware, acknowledged by VMware, we will support that.
And a quick other question. There's a new technology that VMware came out with, which is the I/O filters. And I think it's SanDisk working with VMware and coming up with an acceleration product along those lines. Is that something that Flash FVP are going to do as well?
Yeah, so that's a very new thing. I just saw some news. Probably I will expand that question to general about the unique features. When you talk about the product, you basically do a comparison between product and product. My view is you best understand your needs first before you compare the features. And also for us, I do believe there are lots of advanced features which is stand out. Is we truly clustered. We support all these read and write, and also we support all the built-in VFS features. Apart from that, like I mentioned earlier, we not only just do the acceleration at this stage, we also introduce lots of intelligence to provide you with a VM-centric policy to address your VM needs. So if we can go back quickly to that slides, I will show you. Okay, you'll see that's features I want to highlight here. We not only provide a cluster solution, but also provide a scale-out performance. And down the track, lots of new things coming up. We don't have probably not enough time to release today. But caching is only one component of this total solution. We introduced the memory. I believe this is very powerful because these days you can easily use compute resources for your storage performance and easily change that. And also we introduced new features called fault tolerance align with your failure domains. For example, if you have a DR situation, you have a VM running on one side, you're concerned about what happens if you have side failure. When you enable that write back, we always consider, make sure when we pick up network peer, align with your domain failure policy, we pick up your alternative side. So all these advanced features, I believe, is very unique in the industry. And for the deployment, you don't need to worry about third-party lots of the components like VSA or drivers or backend storage. It's running at kernel level. It's fully supported by VMware. If you make a call to VMware, it's fully supported if you have FTP installed. Probably lastly, just one slide. If you want to try out, just send an email to us and talk to me afterwards. I can organize the trial license. And if you can use put your card, leave your message here, we are going to send out that. We'll pick up the winner and we'll send out the voucher to you by email.
Well, we'll do the draw at the end, yeah? Okay, was there any other questions? Any more questions? Yeah? Okay, last question, yeah? Thanks, yeah.
What's the percentage of overhead if you use this software?
Yeah, if you want to,
yeah.
Thanks. Sorry, could you repeat the question?
Yeah, the question is what's overhead by putting this software in place? The quick answer is very minimal. We have done lots of testings by enabling all the features, including the compression. So every time we introduce new features, we consider overhead. So because it's running at the kernel level, the overhead is very minimal.
Cool, great. Thank you. Thanks, Frank. Thanks very much.
Thank you, everyone.
Just with the business card drop, if you don't have a business card, we've got some post-it notes.